Hey, welcome back. A brand new space telescope is about to upgrade significantly our understanding and our view of the universe, and it's almost ready for the launch pad, and very early. NASA's Nancy Grace Roman Space Telescope, a first-of-its-kind observatory on a mission to map the universe one panoramic frame at a time. Look at that. It's ready to go, get this, 8 months ahead of schedule. Joining us now, Bear Witherspoon from NASA's Goddard Space Flight Center to tell us about the technological marvel. Bear, good morning. Hey, first explain what you're wearing here and what we're looking at, as I guess we get a look before it ships out to launch.
Yeah, no, happy to be here. The outfit is a little silly, isn't it? I'm wearing what we call a bunny suit. It's because I and all the humans in here are the dirtiest things in this clean room. So this is to protect the hardware from us. So it also helps that you guys don't know what I'm actually wearing under here.
That's right. You could be wearing your Hawaiian shirt or whatever it is.
That's right. You wouldn't know. So what you're seeing behind us, though, is the Roman Space Telescope itself. Some people would say that's the game ball. That's the one that is going to be 1 million miles away from Earth when we launch this fall.
I mean, and this has been in the works for a long time. Talk about what goes into preparing this and what you're feeling as it's sitting right there in all of its glory.
Yeah, that's a great question. I mostly pride and awe of my team. It's been millions of people hours have been put into making that back there, and it's just so wonderful to be this close to launch. And obviously it's complete right now. That's fully built and assembled, and it's taken many years to get here.
Millions of hours.
Mostly just excitement. I'm thrilled.
It's amazing. And we can imagine, even though we can't see your mouth, we can imagine. This, talk about why we're putting millions of hours into this. What is the mission for this telescope?
So great question. So there's quite a few things that we're going to do with it. The main one is someone described it to me this way. There's a pie chart, and that is all of the stuff in the universe, right? And about a sliver that's about 3 to 5% is matter, is atoms, and the rest of it, meaning about 95%, is stuff we don't understand. It's called dark energy and dark matter. So this is trying to figure out that 95% of the stuff in the universe that we just don't know how it operates, and we have just notions and theories about that. Wow. So that's one thing. The other thing we're going to do is we're going to do a demographic census of the Milky Way galaxy. We're going to find out what our neighborhood is like, right, in terms of all the planets that are throughout the Milky Way galaxy.
Wow. What did you do in preparing this telescope, or what are you doing in this mission? And then also, today, like we saw these new photographs of the Milky Way galaxy. They were amazing. I guess you're telling us that we're going to get even better and closer and more expanded look at all of it.
That's right. So talking about the mission, we are going to map most of the sky with that, as you said, that panoramic view. We have a large, I keep doing this with my hands. This is the size of our detector array. So we just get to map the entire sky and do it over and over again with Hubble resolution, if not better images. So the amount of data that's going to come down is just going to be substantial. Me personally, I was what's called the payload systems engineer. The part that takes the pictures, like the telescope itself, there's a truss that holds the telescope, and then there's some cameras that go into that truss. That bit is the payload. And so I had to make sure that all played nice together, as well as attached to the spacecraft and then put it through a bunch of tests to make sure it worked.
Whoa, cool. Okay, so the telescope, we're told, and it looks like it's about the size of a semi-truck trailer, and the camera is the size of a fridge. Talk about the technology. We're not just putting a Nikon, or a Canon inside of there. What is the technology we're using here?
So a good way to explain it to people is that detector array is a 300 megapixel camera. So it's just to actually display an image. We don't have a television screen big enough to display. It's just bonkers. So there's that. And so that, as I said, is going to help us map everything and just take the amount of data that's coming down. It's a different way to do astronomy, right? Typically with astronomy, an astronomer writes a paper, says, will you please point your space telescope at something? And then you get the data back. We are going to give that data to the world and say, is there anything that you want to look at in more detail that you found?
Oh, wow.
If so, we can use James Webb and look at what you want to know back to the dawn of time, if you like.
Oh my gosh. So we're limited on time, but we want to know, like, what's the timeline here? It's about to launch. When will it be up there? When can we actually be seeing some of the images here?
So our plan is that we're launching in fall, in September, and about 3 months after that, it takes about 3 months to set everything up and get to a state where the observatory can give you the science images that we're all looking for. So the holidays, it'll be a nice present for everybody.
It'll be a nice gift for everyone. Bear Witherspoon, thank you so much for joining us, for explaining so well what this project is, and we can feel your excitement, and we can't wait.
Thank you. Very, very happy to be here. Appreciate it.
Love the comment about how we don't know what he's wearing. We don't know but we can feel it. We can feel that he's.
I wish I knew what he looked
excited.
like.
That's right.
But I mean, this is like high level stuff, and he did a good job explaining
Right.
to the rest of us what's actually going on.
Camera the size of a fridge. Okay.